Welcome to my presentation. In this presentation, we shall see the procedure of matrix row operations. Okay, so let us see how we can do a matrix row operation. So let me write that here. We'll perform a matrix row operation. Let us say we have a matrix of this kind. We have a matrix of this kind: 0, 1, 3, 4, -1, 2, 0, 3, 2, 3, 4, and 5. I'm just making up some numbers. In here, what we want to demonstrate is that two rows of a matrix may be interchanged. Sometimes we want to do that, and the way to do that is as follows. We can write, since this is row 1, this is row 2, and this is row 3, as we can see. We can interchange the rows, and then we can write the second row as the first row, -1, 2, 0, 3, and then the first row becomes the second row, so 0, 1, 3, 4, and the third row remains as is, 2, 3, 4, and 5. So this is what we have done. We can interchange two rows of a matrix may be interchanged. This and this, we have interchanged row 2 with row 1. That is possible, and that is one of the rules of matrix operations. So let us say the elements in any row may be multiplied by a non-zero number. So let me demonstrate that that property of that. Let us take an example and then explain that. Let's say I have a matrix of this kind: 2, -4, 6, -2, and then 1, 3, -3, 0, 5, 3, 4, and 5. Let's say we have a matrix of this kind, and in here what we're trying to say is that the elements in any row may be multiplied by a non-zero number. I can take row 1, since this is row 1, this is row 2, and this is row 3. If I want to simplify, I can the new R1 I can write as existing R1, existing row 1, and then divided by 2 throughout that row. That means we're going to take 2 divided by 2, which is equal to 1, -4 divided by 2, which is equal to -2, 6 divided by 2, which is equal to 3, and -2 divided by 2 is equal to -1. And the second row and third row we can write as is, which is 1, 3, -3, and 0, 5, 3, 4, and 5. So this is the way we can write it. Or if we want to write it in a little bit more clear manner, we can also write it this way. The new matrix after this dividing by 2. For the first row we have 1, -2, 3, -1. The second row is 1, 3, -3, 0, and then we have as a third row 5, 3, 4, and 5. So this is the way we can use the properties of matrices to be able to divide a particular row throughout the row by a non-zero number like this. The third property which we want to understand and which we will be using frequently is as follows. the element in any row may be multiplied by a non-zero number, and these products may be added to the corresponding elements in any other row. So what we mean by that is as follows. I'm going to explain that by explaining by this example. Let me make up a matrix. So let's say we have 1, 2, 2, negative 4, and then we have negative 6, negative 11, 3, and 18, and then the third row is 1, 2, 3, and 4. Let us say we have a matrix of this kind, and we want to be able to multiply a row by a non-zero number and then either add it to or subtract it from one of the rows. And the way to do that is as follows. We're going to write it out as these different steps in here. So we'll write the first row as is, since this is row number 1, this is row 2, and this is row 3. We'll write the first row as is, 1, 2, 2, negative 4, and the second row we want to make it equal to 0. So if we want this location to make that location as equal to 0, the way to do that is as follows. We're going to then say we're going to multiply the new R2 is going to be equal to 6 times R1 plus R2, and the way to do that is as follows. I'm going to write them down here and you will see that. So 6 times 1 plus negative 6, or I can write this one as negative 6. 6 minus 6, that is going to be equal to 0. Then the second one we have here is 6 times negative 11 6 times, this should be 6 times 2 minus 11. 6 times 2 is 12. 12 minus 11 is equal to 1. And then the third one here is 6 times 2 plus 3. 6 times 2 is 12. 12 plus 3 is equal to 15. Then we have 6 times negative 4 plus 18. 6 times negative 4 is 24. Negative 24 plus 18 is going to be equal to negative 6. And in the third row, nothing is happening, so we're going to write it as is 1, 2, 3, and 4. What we have done here is we wanted to transform the second row, first column location to 0. So therefore we multiplied multiplied the first row by 6 and then added it to the second row, and then I've shown you the details in here. And when we do that, that particular location becomes 0, and then we really it really doesn't bother us as to what the other numbers change to, but we need to do the math correctly. So therefore, if we were to write the same thing a little bit more cleaner, this is how it's going to look like. 1, 2, 3, negative 4, that is the first row. The second row is 0, 1, 15, and negative 6, and the third row is 1, 2, 3, and 4. I have not done anything in here, but I have just written down whatever we have done operations in here. We have written it down in a much cleaner manner here, and this is how we can do these operations. So the operation which we have just performed is the elements in any row may be multiplied by a non-zero number, and these products may be added to the corresponding elements in any other row. So we will use these three properties which we talked about in this presentation and then apply to solving problems as we advance. In my next presentation, we shall see what row echelon form is.